Hello, I'm Mamie Addy, and I was presenting over the Topex Poseidon mission. The Topex Poseidon was the first satellite to have highly accurate measurements of global sea levels. It produced the most accurate global maps of tides ever. It also provided the first continuous global coverage of ocean surface topography. This data that was collected helped lead to a better understanding not only of El Nino and La Nina, but climate research. Production of the first global views of seasonally changing currents was also provided. It was an Earth satellite designed to measure ocean surface topography with unprecedented accuracy. Topex Poseidon spent 13 plus years in orbit, improving understanding of ocean circulation and its impact on global climate. A bit of background about the mission and satellite. Uh, the satellite was launched in 1992 and was a joint venture between France's CNES and NASA. It was actually the second element in NASA's mission to planet Earth, a program designed to measure the global climate system that accounts for global warming or cooling and the El Nino phenomena in the the Pacific Basin. The mission was supposed to last for 3 years, and she carried a 5 year store of expendables. The mission did last for 13 years in total. The satellite's pitch reaction wheel, which helps keep the spacecraft in its proper orbital orientation, stopped working. This is what ended the mission on January 18th of 2006. The Topex Poseidon brought a variety of equipment to space to help with her mission. She was equipped with a GPS system and an altimeter to take measurements. She was in space for 13 years collecting data. Topex was sent to study the ocean topography. The information sent back was used in a variety of ways, including how the oceans influenced and responded to weather and climate, and also to make global tide maps. Knowing where the satellite was in position to the Earth made it possible to have precise measurements. This was accomplished by a network of 24 military satellites that were in orbit. Signals were sent from the satellites to the Topex Poseidon's GPS receiver to use to calculate its position in orbit. This, in addition to the augmented ground processing, allowed this position to be accurate to just under 2 inches. Along with the GPS system, the Topex was also equipped with other apparatus. One of these was its altimeter. The altimeter was an instrument that sends radio pulses down to the surface of the ocean, then measures the length of time it takes for the pulse to be reflected back. The altimeter can measure large amounts of the ocean surface quickly, but water vapor from the atmosphere could interfere with this data as it's being sent and causing a timing error in it. To help correct this issue, a microwave radiometer was used to help adjust for errors caused by the water vapor in the atmosphere. The Topex Poseidon took 10 days to circle the Earth. It learned that the ocean was rising at an uneven rate. Due to this, scientists learned that El Nino and La Nina had global reach. They learned that they were not limited to the tropics, but extended into the Pacific. The readings that Topex was able to complete helped to predict the El Nino in 1998 by rising of the ocean level and La Nina in 1999. La Nina was the trade winds getting stronger and sending more warm water west. This increases the upwelling of cold water off our west coast, pushing the jet stream northward, which can bring droughts to the south and more rain in the north. And with El Nino, the trade winds aren't as strong and warm water is pushed to the west coast, and these warm waters cause the jet stream to move south. The south has more rain, and the north ends up with more dry and warm. The Topex Poseidon mission was continued on by its successors, the satellites Jason 1, Jason 2, and Jason 3, with the Topex flying in tandem with the Jason 1 for several years, Jason 1 having been launched in 2001. The data sent from the Topex Poseidon and the other satellites has been incredibly useful in numerous ways. This data is used to help in forecasting and navigation, to name just a few. Using the height and temperature of the ocean can help to lessen the impact of storms, such as El Nino. This information can give people more time to prepare for these storms. This can be seen with Hurricane Rita in 2005. The Jason 1 and Topex were able to observe a line of warm water in the Gulf that was up to 23 inches higher than the water surrounding it. Since hurricanes feed off heat stored in the ocean, they were able to better predict the direction of the storm. And since the ocean expands and contracts when it heats or cools, sea level height is used as a marker for water temperature and heat content. This data can then be used to help forecast a hurricane strength. This will also help with saving lives and saving property. The continuous data of ocean levels in the Pacific that was sent by Topex helped scientists better predict the El Nino occurring in 1997. This data was comprised of the ocean topography and the temperature measured. In addition to forecasting, the information provided by the Topex was used for navigation. The almost real-time data sent about currents, waves, and eddies have been used by sailors to assist in navigating the ocean surface and underwater. This data and the data from the Jason satellites have also provided information on the eddy currents in the Gulf of Mexico. An eddy current is water running contrary to the main current, from Merriam-Webster's dictionary. This information helps marine operators schedule their offshore operations and also helps them manage these operations safely. The data produced by the Topex Poseidon was unprecedented. The unmatched accuracy enabled oceanographers and climatologists to observe long-term variations in the ocean. These included global sea levels and seasonally changing currents. A full orbit was 10 days in length and covered approximately 90% of the world's oceans. One scientist said that one cycle showed as good an image of global circulation as the previous 150 years of ocean measurements at sea has shown. The collected data is used regularly by researchers and communities worldwide for numerous reasons, including climate forecast and hurricane tracking. Some lesser-known uses are also for fisher. The Topex Poseidon was an unprecedented satellite. It provided the first continuous global coverage of ocean surface topography. The data that was collected has helped lead to a much better understanding of El Nino, La Nina, and the climate research. Scientists are now taking that research and what has been learned a step further. They're now also starting to look at the water on the continent.